Hello everyone, welcome to Cracku DLR series. In this series, we are covering 100 plus CAT level DLR sets for CAT 2026, covering easy, moderate and hard difficulty levels. In this video, you will get one complete DLR set and the PDF will be mentioned in the pinned comment. Download it before you start. Pause the video, try solving the set by your own and continue to watch the video. If you're preparing for CAT 2026 and want a serious DLR practice, then this series is for you. And if you want more DLR sets, we have thousands of them. It's very simple, just go to Google and search Cracku DLR sets.
In this question, we are told that there are 9 boxes and each box has 3 sacks. So we have to figure out how many numbers, how many coins are there in each of the sack in the 9 boxes. So let us draw 1, 2, 3 boxes in the first row, first column, 3 boxes in the first row, second column, 3 boxes in the first row, third column. Similarly, we'll put 3 boxes everywhere. 1, 2, 3. Here also 1, 2, 3. 1, 2, 3. 1, 2, 3. Now we have been given the median for some of the boxes. The median for the first row, second column one is 9. This would imply that this number has to be 9. If you are assuming that the numbers are already in ascending order, this would immediately imply that this number also has to be 9 because this number has to be greater than the median. In the first or third column, this is 6. So this number will be greater than or equal to 6. This number will be less than or equal to 6. We are told that the median of the second row, first column is 2. So this is 2 over here, the middle number. And in the third row, it is 8. So this is 8. We have just filled the information that is given in table 1. Let us now look at table 2. Table 2 is interesting. It is telling us the number of coins in the 3 sacks which is greater than 5. In the first one, only one number is greater than 5. This would imply that the largest number, this one, has to be greater than 5. What else does it say? It says that 2 of the 3 statements given over here are true. Now this would imply that either this is true and at least one of 1 and 2 is true. Why is this important? Because if you're looking at the information that is given over here, the first one says that the minimum number in the 3 sacks is 1. So it is saying that this number is 1. This is what the first point is saying. The second point is saying that the median of the 3 sacks is 1. So the second one is saying that this is 1. But if the median is 1, the smallest number also has to be 1 over here. Like we put 9 in the largest number over here because the median is 9. The number to the right of it will be greater than or equal to 9. So we put 9 over here. Similarly, if the median is 1, the smallest number has to be less than or equal to 1. So this will be 1. So even if 1 is true or 2 is true, one thing that we can infer is that the smallest number will be 1. And using that concept, this number we can say will be equal to 1. Why exactly are you saying this? We are saying that 2 out of these 3 statements are true. So 2 out of these 3 are definitely true. This is given by the number of asterisks over here. So this would imply that at least one of 1 or 2 is true. Now if 1 is true, the minimum number is 1. If 2 is true, both these numbers are 1. In any of the case, the minimum number over here is 1. So therefore, as at least one of 1 and 2 is true, this would imply that the smallest number in the first row, first column has to be 1. We can probably infer more, but let us first look at all the information. If you look at all the information, we can solve it faster. Let us look at the second one over here. Here it is saying that 2 numbers are greater than 5. So this is 5, this is greater than 5, this is greater than 5. That is already taken care of. And this would also imply that this statement is true. What this is essentially inferring is that this number has to be less than 5. Less than or equal to 5 because that number is not greater than 5 and the minimum number is not 1, the median is equal to 9, it is not equal to 1. This is what we can infer by looking at this information. This would say that 2 numbers are greater than 5, they are the median and the largest number, that is taken care of. So the smallest number is less than or equal to 5. Now we also know that the average of all the boxes is a distinct integer. So the sum of the 3 numbers which are present in any box has to be a multiple of 3. The sum of the largest 2 numbers is 9 plus 9, which is 18. Because we want it to be a multiple of 3, this number has to be 3. Because if it is, the sum is 18. So if it is 1, the sum will be 19. If it is 2, the sum will be 20. Sum is 21 if the number is 3, so which is a multiple of 3. For 4 and 5, again, it's not a multiple of 3. So the total is 21. This would imply that the average is 7. Why is the average important? The average is important because we are told that the average number of coins per sack are all distinct integers. And we can infer that the numbers have to be, the averages have to be either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. We have already found out the box whose average is 7, that is in the first or second column. We have to figure out the remaining boxes. Let us look at the third box in table 2, this information. Here we are told that two numbers are greater than 5. So this number is also greater than or equal to 5, which is kind of known because if the median is 6, the largest number will be greater than or equal to 6. But let's just write it. This is greater than 5, which is obvious. We can actually say that this is greater than or equal to 6. And this number is less than or equal to 5. What other information do we have? We have the information that one of the three statements over here is true with respect to this box. That statement is definitely not the middle one because the median of this box is 6. It is not 1. So either the minimum is 1 or the maximum is 9. One of these two has to be true. We'll just put it over there and go to the next one. Here we are told that two statements are true and one of them is greater than or equal to 5. We know that the middle statement is false because the median of this box is 2. So this has to be true, this has to be true. This would imply that this is 1 and this is 9. And the sum is 12, so the average is 4. So it is not, this also can be crossed out. Here we are told that none of the three boxes is greater than 5. So this is less than or equal to 5. This is less than or equal to 5 and this is less than or equal to 5. Now only one of these three statements is true in this particular box. And we know that it is not the third statement because all the three numbers are less than or equal to 5. So the maximum number cannot be 9. Now again, either the first one is true or the second one is true. This would again imply that this number has to be 1, the smallest number. The smallest number has to be 1 because if the median is 1, it would imply that the smallest two numbers are 1. If the minimum number is 1, it would imply that this number is 1. In both the cases, either if 1 is true or 2 is true, the minimum number is 1. So we are saying that the minimum number is 1. This would essentially imply that this statement is true and only one of the three statements are true. So this statement has to be false. By inferring that this statement is false, we can say that this number is actually not equal to 1. This will be greater than 1. It will be 2 or 3 or 4 or 5. Again, we can probably infer more from this, but let us ignore it. Go to the next box. Here we are told that all three are greater than 5. So this is greater than 5. This is greater than 5. This is greater than 5. And one of the three statements is true. And that statement cannot be this one or this one. Because if all the three numbers are greater than 5, the minimum number will not be 1, the median number will not be 1. So this has to be implied that the third statement is true. So this will be 9. Let us look at the next one. Here we are told that all the three are again greater than 5. So this is greater than 5. This is greater than 5 and this is greater than 5. Again, the first and the second one will not be true in this particular box. The third one will be true. So this is 9. 9 plus 8 will be equal to 17. We need a third number. Adding 17 to it should get us a multiple of 3. That number has to be 7. Because 7 plus 8 plus 9 is 24. Any other number, whether it is 6 or 8 or 9, if you are adding to 8 plus 9, you won't get a multiple of 9. What is the sum of 7 plus 8 plus 9? That is 24. So the average is 8. So this is 8 over here. So we can cancel 8 also over here. Let us look at the next one. Here we are told that two numbers are greater than 5. So this is greater than 5. This is greater than 5. And two statements are true. If two statements are true, the first thing that you can infer, is at least one of the first statement or the second statement is true. And this is a very important concept because like we discussed multiple times, if either one of the first or the second one is true, the minimum number has to be 1. So this number is 1. Now we have this number is actually greater than 5. So the median is not equal to 1. This would imply that the maximum number, this one has to be 9. Now we are looking for a number which is greater than 5 such that if you add 1 plus 9, that is 10 to it, you are getting a multiple of 3. So that number has to be 8. Next, if you are looking at the next one, here we are told that all the three numbers are actually less than 5, less than or equal to 5. And two of the three statements are true. Now, two of the three statements are true would imply that the third one is false. Because all the three numbers are less than 5, so the maximum number cannot be equal to 9. So this one has to be true, this one has to be true. So this is 1 and this is 1. Now this is what we are able to infer by immediately looking at it. Now let us try to figure out certain things. What are the numbers that we have been able to eliminate? The averages we have found out for the different boxes are 4, 7 and 8. Which of these boxes will have, and this actually is 6, that also we have identified. 9 plus 8 plus 1 is 18, so this is 6. Which of these boxes will have an average of 1? Which of these boxes will have an average of 9? If you're looking for an average of 9, all the 3 numbers have to be 9. The only possibility is this one, so this will have to be 9. There is no other box which is remaining such that all the 3 numbers are greater than 5. Because in this particular case, we have found out that the 3 numbers are 7, 8 and 9, its average is 8. There is no other box where all the 3 numbers are greater than 5. So here we got 9. Which of these boxes will have an average of 1? Here we want all the 3 boxes to be less than 5. So it has to be either this one or this one. Now if you're looking at it, we know that all the 3 numbers have to be 1, but in the middle box over here, we know that the middle number cannot be equal to 1. It has to be greater than 1. Why is that the case? Because if you remember, in this middle box, only one of the 3 statements is true. We know that in the middle box, this number is false. The maximum number is not 9. All the 3 numbers are less than or equal to 5. So either this one is true or this one is true. Like we discussed earlier, if any one of the 2 numbers are true, it would imply that the smallest number has to be 1. So we know for sure that this number is true. And because only one of the 3 statements is true, the median cannot be equal to 1. So this has to be greater than 1. And therefore the average cannot be equal to 1. If the average is 1, all the 3 numbers have to be 1. This would imply that this is 1 and this is 1. So this is equal to 1. So this also is cancelled. Now the only 3 averages we need to find out are 2, 3 and 5. So the sum of the 3 numbers in the 3 sacks has to be either 6 or 9 or 15. What are the 3 boxes which are remaining? The 3 boxes which are remaining are this one and this one. If you're looking for a sum of 6, it cannot be this box because the middle number itself is 6. It cannot even be this box. Why cannot it be 6? Because we already have 1 and we have a number which is greater than 5. The sum of these two itself is greater than 6. So the sum cannot be equal to 6. The sum will be equal to 6 only over here. And if the sum is equal to 6 over here, the only possibility is that it is 1, 2 and 3. Why is that the case? Because we have 3 numbers. We know that this number is 1. We know that this number is greater than 1. And this number will be greater than the middle number. So if the median is equal to 3, for example, the last number has to be greater than or equal to 3 and the overall sum will be greater than or equal to 7. So the median has to be 2. If the median is 2, the sum of these 2 is 3. Therefore, the third number has to be 3 itself. That is the reason it has to be 1, 2 and 3. 2 is also cancelled. Now we have only 2 averages which are remaining, which is 3 and 5. If it is 3, the sum has to be 9. If it is 5, the sum has to be 15. Which of them will be 9? Which of them will be 15? We know that this cannot be 9 because the middle number is 6. The large number will be greater than 6. So the sum itself is greater than 12. So this has to be 9. So this will be 3, the average, and this average will be 5. If the average is 3, it would imply that the sum has to be equal to 9. And if the sum has to be equal to 9, 2 of the statements are true. So the largest number cannot be equal to 9. If the largest number is equal to 9, the sum will be equal to, will be greater than 9. But we want the sum of these 3 numbers to be equal to 9. So this is true. This is false. So these 2 have to be true. So the median has to be 1. And therefore the largest number has to be 7. If you're looking at the only case remaining of this one, the sum of the 3 numbers has to be 15. And we know that only one of them is true. Now that one statement is not the middle statement because the median is 6, median is not 1. That statement will not be this one also. Because if the largest number is 9, 6 plus 9 itself is equal to 15. Therefore the smallest number has to be 0. That is not possible. So this also is false. So this will be true. So this will be 1. 1 plus 6 is equal to 7. So this will be equal to 8. And the average of these 3 is equal to 5. Let me clear some of them so that we can go ahead and answer the questions that follow. Now let us go ahead and answer the questions that follow. What is the total number of coins in all the boxes in the third row? The averages are 8, 6 and 1. That totals up to 15 into 3 will be 45. So the answer is 45. You can just sum up all the numbers in this particular row, you will get 45. How many boxes have at least one sack containing 9 coins? 1, 2, 3, 4, and 5. For how many boxes are the average and median of the number of coins contained in the 3 boxes the same? It is not the same over here, it is 1 and 3. It is not the same here, it is 9 and 7. It is not the same over here, 5 and 6. It is not the same over here, 2 and 4. It is the same over here. So we have 2 and 3, this one, 2 and 2. It is the same over here. It is 9 and 9. It is the same over here. It is 8 and 8. It is not the same here. It is 8 and 6. It is the same over here. So we have a total of 4 such boxes. How many sacks have exactly 1 coin? 1, 2, 3, 4, 5, 6, 7, 8 and 9. In how many boxes do all the 3 sacks contain different number of coins? That is the case here. 1, 2, 3, 4 and 5.
Stop wondering which IAMs will call you. Get the most accurate answer. Cracku's IAM called Predictor analyzes everything, your academics, your work experience weightage and even the JAB process, all based on the latest RTI data. Know the exact cutoffs and your precise chance in seconds. Ready for clarity? Just Google search Cracku IAM called Predictor. Your personalized IAM report just is search away.